All right, let me put my presentation hat on and get my presentation markers. And then in true presentation style, I need 3 colors, Drew.
Well, there's 4 right there, buddy.
Which, oh! Oh! Where's my black at?
I didn't get you black.
Oh, okay. What is binary? What is binary? Nobody knows. Okay, so this is not really for you people in this room. This is for you people outside of this room that aren't here. The reason being that y'all all know this, but a lot of people think that like binary has something to do with software or like computers or something. But I mean, we all know you've never seen anybody with a special binary keyboard that just has the 1 and the 0 key and they're just like pecking away at it like I'm programming the computer. Wah! That never happened. Just didn't, right? So what is binary? Where does it come from? Why do we talk about it? Now, I want you to imagine that this is a comb. And I want you to imagine that this is wool. And hopefully, if you had a childhood as good as mine, you can see what's coming here. I'm just going to rub them together, rub them together, rub them together. And now this comb has a magic property. I want you to pretend that right here is a slight drizzle of a water fountain. And I go, tss, and it goes leak, 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 but it's like a constant stream. And I take the comb and I put it next to it, and the water all of a sudden just goes like this, right? Because there's the static on the comb, and as you guys have seen this before? Okay, good. I just want to make sure, right? Yes. So that's what I like to call a semiconductor. Because it's not really conducting any electricity, but it's doing something. So in the computer world, we have a semiconductor called, well, the transistor is made of a semiconductor. A transistor is a thing that basically is affected by electricity, kind of like water is, where it just kind of changes the direction of where it's going. So you've got a collector line that is represented here. This is called the collector. Oops, collector. And then you've got a line coming in here. It's called the base. And then you've got a line coming out down here called the emitter. And what happens is the collector has a constant stream of power. Say it's just like constant 5 volts. And it's going nowhere. And then the base is a selector line. And so the base is either going to be turned on or off. And the base doesn't need to have the same voltage as the collector, but in a lot of cases it ends up being that way. So let's just say this is 5 volts too. And then you got the emitter. And what happens is, say that there's 2 types of these transistors. There's the ones that are on by default, meaning that if the collector has power, then it goes through to the emitter unless the base has power. And then there's the ones that are off by default, which is like the kind of the more normal one, which is that the collector can have power, but it doesn't go through until there's also power on the base. Anyway, so this has constant power. The power could be on, could be off. It's the selector. And then based on the state of the selector, the emitter is either going to let the power through or it's not going to let the power through. So what does this have to do with binary? Am I going to say because it can be on or off? No, that's not what I'm going to say. So I'm going to get rid of this real quick. I'm going to draw you another one. It's going to be bigger. It's going to be better. It's going to be better because it's bigger. Now, to simplify things, because you can basically take one of the, you can take transistors that are the off by default type, and then you can kind of like configure them such a way that you end up with a transistor pattern that's on by default. But I'm just going to draw it in different colors instead. So we're going to say that this is our power line. Actually, I'm going to get red. So this red thing right here, this is our power line. All right, and then we're going to have a selector line that runs beside it. You can imagine this being on a circuit board. Okay, and then I'm going to throw a transistor down there, and this transistor is going to be purple, and purple is going to represent the transistor that is that is off by default. And then I'm going to throw another transistor on here that's going to be brown, and that's going to represent the transistor that's, no, it's going to be orange. Colors are hard. It's going to be orange, and it's going to be a square. So this is off by default, this is on by default. So what we have here is power's always on. So it's coming down to this little transistor. Power's always on, it's coming down to this little transistor. All right? And then this one is always on. So it's got some power coming out of it. Well, I'll have to draw this a little longer. And this one doesn't have any power coming out of it except for when, so we got the selector line, it's going to go into the transistor here. We got this selector line going to go into the transistor here. So when this selector line is on, now this thing lets out its power. So I'm just going to draw that. We'll go down there, go down there. Now why did I do that? Because we've got another transistor here. Whoops. Might have drawn that too close, whatever. We've got another transistor here that's off by default, another transistor here that's off by default. Then we've got another transistor here that's on by default, another transistor here that's on by default. And then, surprise, surprise, we're going to have another selector line that's going to run through. And let's see, it's going to run down here. Yeah. And so this selector line is going to go wherever it's going to go, but goes in there, goes in there, goes in there, goes in there. So we've got two selector lines. And what happens is there are now 4 different states that can happen. So when both selector lines are on, the only flow is from right here. Because this one turns on, and then this one turns off. And then this one turns on, and then this one turns off, and then these two are off because that one's off. So then if I have, so this becomes 1, 1. Now, if I have this one on and this one off, then what's going to happen is that this one turns on, and then I have 1, 0. And if I do it the other way, where this one is off and this one is on, then I have this one. I might have drawn these in the wrong order. Let's see. No, this one's on, this one's off, this one's on. Then this one turns on. So now that's 0, 1, meaning like this is either on or off. It's 0, 1. This is either on or off. It's 0, 1. And then I have, if this one's off and this one's off, I have 0, 0. Now, ladies and gentlemen, binary is a physical addressing scheme for physical objects. It is not digital at all. And to kind of give you an idea of how this works, does anybody know the letter A in binary? I will tell you. 0, 1, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. I believe that is the letter 1, or the letter A. This is a capital A, if I remember correctly. So on an old school keyboard, can you guess how many wires there are on an old school keyboard for data lines? 8 of them. Do you know why? Because there's 8 wires. Do you know what happens when you hit the letter A?
The second and the last one.
Yes. And I think I might actually have this. I'm not sure if I have this backwards or not. This would be capital A. So hold on. Let me explain it the other way first, because it's a little bit easier to explain if I start with the lowercase a. Yeah. So that one is the lowercase a, if I am saying this stuff correctly. So when you hit the lowercase letter A, it simply turns all these wires on so that then they can go out to the computer. When you hit the shift key, it turns this one off. This particular one here, this is 0x20. No, that's not what it is. That's what it is in something else. Okay, anyway. But, nope, no, don't do that, don't do that. There we go. There we have our capital A if we turn that bit off when we hit the shift key. So a computer functions very much like a music box where you've got, like, maybe y'all have seen this thing where there's the roll of paper or roll of whatever, and it's got like the little, looks almost like Morse code, and then, like, depending on where it is, the music box rolls through and then it plays the right sound. It's exactly how a computer works. There's just a bunch of physical components that when they touch some of the wires, the power on the wire goes on or off. And then when you get really, really complex and you consider that there are trillions of these, as in, like, for every person on the planet, they can get 1 million of them if they've got one CPU. You know, you just hand it to everybody. So there's trillions of these transistors inside a computer. And by arranging them in complex arrangements, you can get it so that when you hit the letter A, those wires go to something like this, where this basically tells it to open up a memory address and then store that letter in memory. And then that causes a chain reaction of something else to happen. And then, you know, a fraction of a millisecond later, the letter A is on your screen because it's been translated from a physical key press to a graphical representation of that key press. So binary is physics. It's wires turning on and off because of semiconductors. If this was useful for you, please go ahead and give that little thumbs up button a nice click. Also, you'll see the notes are in the comments section down below. You can either at the end of the article or right up at the top. Give it a like, tweet, +1, whatever. Thanks.